Hello, everyone. Welcome. My name is Philippe Ozil. I'm a developer advocate at Salesforce, and I'm also French. Bonjour tout le monde. All right. So today, I'm here and excited to talk to you about the new streaming API called the PubSub API. And something that you'll learn is that it's gRPC based. It's a new technology, and I'll be presenting the details of how this works. Before I start typical Salesforce presentation, because I work for Salesforce, I have to show you this wall of text, which means essentially, please make purchasing decisions based on what is commercially available in the product and not on what I'm going to say today. The good news is that the PubSub API is GA, so I should not be making forward-looking statements. So before we jump into the Salesforce part, really, let's just do a little refresh on what is an event-driven architecture. What is PubSub? Because this works with a lot of different technologies. It's not something specific to Salesforce. And the way it works is that it's all articulated around the notion of events. An event being sent from one point, received to another point, or many other points. And events represent really a change of data or change of state for a system. And these can be incorporated also in business processes. So a change of state in a business process can trigger an event. The way this works is that there is an event bus. So here I've taken an example with the Salesforce Event Bus. And there are a number of actions that come to play in a PubSub architecture. So the first thing that happens is that you have a number of subscribers that will connect to the event bus and say, I'm interested in these kinds of events, so notify me if there's any kind of event for this particular type of event. So here I've taken some examples. I'm showing you Flows, Heroku, the Experience Cloud, and some other clouds. But we could also have external applications not even connected to the Salesforce ecosystem. So they start by subscribing. That's the first step. Then there is a publisher. So another part of the platform, or even outside of the platform, starts to publish an event. So here, the event that we're showing here is called Product Sold. So you can imagine that there's a commerce cloud that is selling a particular product. And it will notify the event bus. It will create a new event and publish the event on the event bus. And what happens after that is that all the subscribers that were subscribing to this particular type of event will receive the event itself with the data that is associated with the event. Now, the power of such an architecture is that you decouple the subscribers from the publisher. So when you look at this diagram, all of these subscribers do not know about the publisher. They're completely decoupled. There's no one-to-one association between them. They only know about the Salesforce Event Bus. So that means that publishers can come and join. Subscribers can also come and join. There's no strict coupling between them. So that's really the key thing behind an event-driven architecture. It's fully decoupled. Now, let's take a look more at Salesforce technology, and I'm going to do a little refresh also on the streaming APIs. This term has been used a number of times and probably with different meanings. So here I'm just going to set a base to make sure that we'll all talk about the same thing when we talk about the streaming APIs. And you'll learn that it's not just one API, it's actually multiple APIs that go under this umbrella. And the way I like to put it is that I like to group them in two categories. There are the legacy streaming APIs, which contain generic and push topic. If you're in the ecosystem for some time, you may have heard of those. And the reason why I'm calling them legacy is that we no longer invest heavily on those. So they will continue to work for a number of releases, but Salesforce is not actively developing on those technologies. And you have more current streaming APIs. These are the ones that we're heavily investing in, and they're composed of platform events and changes like capture. So this is really the future. This is really where we're investing a lot. And there are a number of products in the Salesforce ecosystem that will use these technologies. For example, Genie, which was just presented a couple of sessions earlier. Now, whether you talk about the legacy or current technology, this all works with the Salesforce Event Bus. Up till now, there was only one way to connect to the event bus when you were outside of Salesforce. You were using a transport, so a mechanism to relay the event called commitD. This is something that worked for all types of streaming APIs. All 4 streaming APIs were supporting commitD. And today, I'm here to present to you the PubSub API, which is our new mechanism that will work in parallel to commitD, but it's something that we've only deployed for our newest current technology. So when you talk about PubSub API, it's only going to be a matter of platform events and change like capture. It will not support the legacy streaming APIs. And so this is the technology basically that helps you to publish and subscribe when you're on the event bus. The event bus is the same, but there are different protocols. It speaks different languages to the subscribers and publishers. Now, more on the event bus in general, regardless of the technology you use, you can either subscribe or publish with different types of orgs or within or outside of the Salesforce ecosystem. So here in this slide, it's a bit complex, but I have listed all the different types of publishers and subscribers. You'll notice that you can use external apps. There are a number of APIs which allow you to publish events. And there's the new PubSub API also. So this is really the new part here. The PubSub API is something really new, but lets you publish events. When you look back at history, the CommentD API wasn't allowing you to do the publish part. And you can also use the PubSub API also on the receiving end. So that's going to be one of the key advantages of this new technology. You can subscribe and publish using the same API. Prior to PubSub API, you were able to do the publishing on using the REST APIs, for example, and you would then connect using, well, here, the streaming API, which is more the CommentD itself. And then there's everything that is on the platform on the other side of this slide, typical Apex or flows, so either code or no-code solutions to do publishing and subscribing for our events. So I was talking, now let's just focus on the PubSub API. So what is new about this technology? Well, first, there's the mechanism, the transport we use, which is very new. And it's, again, it's a replacement for CommentD. So what does it bring? The first thing is gRPC. gRPC is not a Salesforce-specific technology. It's something invented by Google. It's open source. And what it brings, in fact, is a lot of that advantages compared to a more legacy system. It has a number of things. The first thing being something called protobuf. Protobuf, well, it's a fancy word to describe that there is a schema between the events. So basically, messages are typed, and they have a predefined structure. And the way the API works is that it will exchange the schema with the subscribers before starting to send events. So you will know the shape of the messages before receiving them. It brings a bit more structure compared to the legacy systems. Another great advantage of the PubSub API is that it is using the HTTP2 protocol. Prior technology, we're using HTTP1, but with HTTP2, first, it goes very, very fast. It's about 7 to 10 times faster than typical REST APIs or even CommentD. And it's also bidirectional, so this is a key thing here. The fact that you can listen to event, but you can also publish event backs allows you to go very, very fast because you don't have all the network overhead of doing things like polling, stuff like that. And I think also one of the great news for developers, but I'm really excited about, is that it works with a lot of languages. CommentD, the technology we were using before, wasn't really adopted widely in the industry, really. It was a number of platforms pushing it, but there wasn't support for a lot of languages. But with gRPC, something that is being pushed by Google, a lot of languages use it. So Python, Node.js, Java, whatever technology you can think of, 11 of them have their own native clients for gRPC, so it's really a good news. Before I jump to the next slide, I just want to mention one thing that I skipped a bit. That's the Avro part. We use gRPC for the PubSub API, but we also use a little thing on top of it to make it even faster. We use a technology called Avro, which is essentially compression. So we compress the messages, we compress the content of the messages when we send them with the PubSub API. Just a little tip there, if you start using it, you will need also to use Avro on top of gRPC. But I won't go too much into details. We'll see that later on, maybe in the demo. Speaking of which, time for me to switch to the demo. So how does it work? I'm going to show you an example, and what I like to use is our sample apps. So I'm going to use our e-bike sample app, and some of you may be familiar with it. It's part of a collection of sample apps that my team maintains at Salesforce. This one is a fictitious electric bike manufacturer, and you can find it online on our GitHub repository. I'll share the links later on. But to keep it short, it's an electric bike manufacturer. They have products, so bikes that they sell, and you can browse their product catalog, and you can see the product details. I'm just going to go show you very quickly. Well, this is maybe a bit too zoomed, so let me just zoom out a bit. Yep. So, see bikes, that's what it works. Now, this demo has a little add-on that explains how the PubSub API works. So on top of the regular sample app, there's a little extra add-on that shows you a good use case for the streaming API. When e-bikes sells their bikes, they need to procure them. They need to build the bikes and they need to assemble them. They have a factory that they need to coordinate with to manage reseller orders. So we have shops that are ordering bikes, and you need to provide those bikes to provide orders to a factory. So we use something called reseller orders for this. So I'm going to create a new reseller order very quickly, a draft reseller order, and you'll see that I'll be able to order a set of bikes. Let me just try to reduce this a bit. So I'm in the bike order view. I'm going to drag and drop a couple of items here just so that we have an order. So a couple of bikes here. And I could just change the quantities. I could just fine tune all of this. But the idea here is that we're preparing an order for the factory. And to validate the order, we'll need to send the order to the factory so that they can say, OK, yes, we can build those bikes, or no, we cannot build those bikes. And what we've built here is an integration with a third-party site. The manufacturing site for e-bikes does not use the Salesforce platform. They have their own system. They're outside of the corporate structure. They use their own website. So I'm going to switch now on the side to their own website. Here, let's pretend that this new screen here is the e-bikes manufacturing system. So different technology. It turns out that it's actually a Lightning Web Component site built on Lightning Web Runtime. But imagine that it is a third-party site. And so the goal of our operation here, for the demo's sake, is that we're going to take an order that is on the Salesforce platform and we're going to send it to the e-bikes manufacturing site. And to do that, we're going to use the streaming API, or the PubSub API to be precise. Now, I'm going to show you how the demo itself, and then I'm going to explain a bit how this works. So now that our order is ready on the Salesforce org, what I'm going to do next is that I'm going to move the status to submit it to manufacturing. And as soon as I'm going to click this little path icon up there, this will fire something called a change data capture event, because we're going to be changing the reseller order record. And as soon as there's a change, we're going to send the streaming event. So I'm going to click now. And you can see in a couple of seconds, there you go, order appears in the manufacturing website. How did it work? So I modified the Salesforce record here. This created a change data capture event. And behind the scene, this third-party app was actively listening to the PubSub APIs, and it was listening to change data capture events for the reseller orders object. So we got the order here. OK, it looks good. And well, actually, let me just zoom out a bit because I'm missing a button down there, which would let me approve the order. So once the manufacturing division reviews the order, they can either reject or approve. And we're going to have the second fold of the demo. By clicking approve, I'm going to send a platform event back to the Salesforce platform, and this will update my order status on the Salesforce org. So if I click on approve now, we're going to see in a second that our order is now shifted to approve. So what I shared today is bidirectional communication between a third-party app and the Salesforce org using the PubSub API. So we use, in one direction, we use change data capture, and the other way around, we use platform events. Of course, we could do it. We could architect this a bit differently. I could be directly interacting with Salesforce APIs from within my manufacturing application. I could be using REST. I could be using all sorts of APIs. But here, I really wanted to show you back and forth with the PubSub API. Now, we have a bit of time, so I'm going to show you some code to explain a bit how this works. And we're going to dive into the code that makes the e-bikes manufacturing app work. So what I have, when I connect and start my application, so this is actually a Node.js application that runs, I have a number of things. I'm importing a number of services which will let me connect to the different APIs. And what is important here is that we have two handles here to the two types of events that we'll be using to streaming API events. So the first one is a change data capture event for the order object. You can see here it's order __ change event. And the second one is a platform event to notify that we're changing the status of our order. Now, we do a number of things. And the first thing we need to do is to authenticate. The PubSub API requires authentication with the Salesforce platform. So we do need to authenticate with the platform because we'll need to be able to provide some credentials to authenticate and to send and receive the streaming events. That's one thing. Just like the other APIs, the streaming API, or the PubSub API, sorry, is authenticated. So there's security considerations, meaning that you will only receive the events for which you're authenticated and you have the permissions to view. Then we start to create a PubSub service. Now, in this PubSub service, there's one thing that I want to draw out is that we use a reference PubSub proto file. That's the protobuf format. And I mentioned it earlier. This is something that you get from Salesforce. It's the same file for everybody. And it describes the structure, the schema for the messages. So it will tell you what are the operations. So here, for example, subscribe operation, get topic, publish, which are the core operations. And it will also detail how the request looks like and what is the response format. And if you go, well, scroll down, actually, no, scroll up, sorry, you'll see what are the different fields, like what are the different flags, and you'll see the structure of the information that has been exchanged. But that is, from a high-level perspective, it works for all kinds of events, all kinds of records. After that, of course, every event has a different payload style. But the core thing is that there is this proto format which describes the format of the exchanges with the Salesforce backend. So we prepare this, and then at some point we subscribe to a, before subscribing, we do another thing. We retrieve the schemas. Now, I mentioned that every event has a different format because the payload is different. If you're looking at change data capture for an order object, there are specific fields on that order object, and this is all described in the schema of the object. That is a really big difference compared to commit.d, is that now, before even receiving or publishing events, you need to get a schema that describes all the different fields so that you can make sure that you have the right format for the information. Commit.d was just a wall of text. It's just like text, but unstructured. And it was your responsibility to make sure that you had the right fields in the right place. But with PubSub API, with gRPC, you need to have a schema. And so we need a first operation, that here that's what we do. We retrieve two schemas to figure out what is the format of the messages for the change data capture event and the platform event. Then we subscribe to our change data capture event, And we provide the schema because we need to know the format of our messages. And here, well, that's a new thing also that is part of gRPC, which is not part of commit.d. We have something called a flow control mechanism, and there is a mechanism that lets you basically shut down the client after receiving messages. The reason why we put this in place is that sometimes when there are bulk operations and like you have thousands and thousands of records, this can flood the subscribers. And here there's an internal mechanism that lets you shut down safely the subscribers. So if you want, you can only listen to X number of events and then shut down softly. So it's something you can use or you can decide to ignore it, but it's an interesting addition to the mechanism for doing streaming events, eventing. After that, we have a function that receives all of our streaming events. So here you can see that I'm decoding the payload of our events, looking at the status, looking at the header, and I will only look at events that are update events where we have a new status. This is what it is doing. I can ignore the other events. For example, if I were to delete a order, that would send also a change data capture, but it would not be processed here because I'm only looking at update operations. And if I were to change another field outside of status, I would also not listen to this event. And here, after that, we process the event and we just transfer the information back to the client so that we can refresh the user interface. Now, whenever there is a change that is being pushed from the client, so from the browser, for example, when you click on the approve button in the order, we have a WebSocket server that is also listening, and that will capture this new information. So once we receive a message for the change of status of the order, we'll wrap it up in a format here that is compatible with the schema of our platform event, and we will publish it with this other operation. So using the channel that we described earlier, so that's the manufacturing event __e, which is the name of the channel for the platform event, the schema that we retrieved earlier, and then the event data that we just packed here with all the required fields. And that's how we do the bidirectional communication, receiving a change data capture event and firing back the platform event to notify the Salesforce org. So that's a quick overview of how the code works. I would need a bit more time to show you everything, but all of this, again, is open source, and I'll be sharing the link to this demo so that you can grab it and play along with it. As soon as you get the developer edition, you're essentially free to use all of these technologies. They're all part of the platform. Now, to finish with the slides, we saw an example of the PubSub API, again, bidirectional, subscribing and publishing. And what I want to continue with oops, okay, there we go, is that I want to wrap it up with some key points about the PubSub API. This is meant to support communication with platform events. We saw that, also change that capture, but we can also play with another thing, which is somehow a derived format of the streaming events. It's called real-time event monitoring. So it's generally an extra license, but it allows you to receive events, for example, who is logging into the platform, who is doing accessing report information, all these things, and it fires events using change capture events and platform events. So it goes beyond your custom events. It can also support some monitoring on Salesforce orgs. Now, one thing that is important is that wherever transport you use, whether you use CommentD or gRPC PubSub API, you have some limits. And there are a number of important limits that you can that you need to be careful of. The first one is the number of subscribers. There's a finite number of subscribers that you can have at any point in time. So you need to be careful of not registering too many of them, otherwise you'll hit the limits. And the second limit you want to be careful with is also the number of daily events. So this is quite high, so it's in the millions, depending on the license you have, but it's also part of the limits that you have to adhere. And whatever protocol you're using, the same limits apply. So whether it is the PubSub API or the regular streaming APIs, same limits apply. Another thing that I barely touched on in this presentation is that you can subscribe to the streaming APIs from within Salesforce UI. So if you had, for example, like custom Lightning Web component or an Aura component, you can subscribe to those streaming APIs. And if you were to do that, you would have to use a component called the EMP API. It's available in Aura and in Lightning Web components. And you would have to use this one, but it still uses CommentD at this point. So I'm mentioning it here, but it's not something that is yet ported to the PubSub API. It may be in the future, but it will be completely transparent for you because you'll still be using the same component. It's just the internal mechanism which will be ported to the PubSub API at some point. With that, I'm going to leave you now with some key resources. I've bundled everything into a single link here so you can get everything, going from documentation for the PubSub API, code samples in multiple languages. I just have just a few of them here. There are more on the different websites. There are also a number of blog posts that I wrote. I partnered with the product manager for the PubSub API. There are also some YouTube videos that I record. And there's even also a podcast that is available if you want to learn more. So depending on which format you prefer, you'll find plenty of resources to learn about the PubSub APIs and the streaming APIs in general. And that's it, Marie. Thank you for listening, and I'll be taking questions if you have any.
Anyone is?
Some in the front row. Good students go in the front, right?
Great presentation. On the topic of streaming APIs in general, so historically, one of the other limits that streaming APIs have had is there's no guarantee of deliverability, and sometimes there are dropped events. Is that still true of PubSub API?
Yes, it is true. The same limits and the same constraints about this apply on the bus. Now, there is an ongoing, I think it's a pilot at this point, that will guarantee when you're working with Apex that the events are at least published correctly to the event bus. So we're working on that, but it's also the nature of the streaming APIs. Because it goes so fast, there's no commit. It's not a database, like a transactional database, so there's no guarantee that it will be delivered. One thing that I did not cover in my presentation is that you still have the same mechanism of replay IDs. So each time you send a message, there is a number that gets increased, which is called a replay ID. It just increases each time there's a message going on. And you can always replay up to a certain point in history during something called the retention window. So you have about 48 hours on which you can replay all past events that are kept in memory on the bus.
And do those contribute to the daily limit, the replay?
So the limit is the number of events that are published, not subscribed.
But if you're replaying it, theoretically you're republishing it, right?
It is already published on the bus, so no, it's just the. I don't think it counts on the limits. No, it's really the publish operations when you call eventbus.publish that really tracks the limit. It's not the fact that the bus is sending it back to the client that is really is subscribing. Yes, next one.
Thank you. For the EMP API, I know you said it's not in the plan, but what's the horizon, or there is no horizon? Is it even on the roadmap? Like, when would you use EMP API with the new protocol?
I haven't seen any update plans for this. The reality is that it works for now, and I don't think we're going to change this soon, honestly. The problem with the MPI API is that it's pretty powerful, but it has one big drawback. The main drawback being the number of active subscribers. This limit will get reached very easily. So you cannot basically have one connection open, one subscriber open for each and every Salesforce users, because you'll very rapidly reach out the numbers of concurrent listeners to streaming APIs. Streaming APIs are in fact generally best used when you do integration between systems, not necessarily in the UI. And what I did share today, I was using, of course, a user interface because it's easier to demonstrate. But normally it's more like a system-to-system integration rather than a UI-to-UI integration.
Yeah, plus one for me for rising the limits for AMP API. And when I get it right, there is no benefit when I use just platform events on platform using the new API, the new streaming API. There's no benefit when I use a subscriber on the client.
Well, the benefit is really the fact that now you have a single client to do publish and subscribe outside. That's the thing. You don't need to juggle with multiple clients because the comedy wouldn't let you do the publishing part. So that's one of the benefits, I would say. And it goes faster. Again, if you have a lot of events, like an external client that needs to do a lot of volume, it will go way faster than Command-D. Last one.
Yeah, so it's kind of, sorry.
No worries, I'll be standing right next to the podium at the end and you can still talk to me.
Okay, thank you.
Okay.
Thank you for the presentation, first of all. I have two questions, if that's possible.
Sure.
The first one is, you talked about the possibility to shut down the client.
Yes.
When you reach a cap. Does the client still listen to or is still subscribing and waits for that cap to be reached again automatically, or do you have to programmatically relaunch it?
So no, you would have to programmatically relaunch it. Okay. So it's, I mean, depending on the technology you're using, you will get a signal back when it's shutting down, and you can automatically reconnect, or you can wait for a certain time. It's up to you.
Okay, and the second one is, for example, there's a published event that fails on the Salesforce side. Is it lost forever, or can you still replay it using the replay ID?
Yeah, so that ties back to Rob's question earlier. It depends on how you publish the event. There are different mechanisms for publishing. If we just talk about Apex, for example, there are two modes. You can publish with a transactional manner, so you can basically you can do a locking operation that will only get you back, resume the transaction once the event is published. Or you can just publish in an asynchronous way, and if it's asynchronous and it fails, well, then you lost the message. Yeah.
No, here I'm really talking about it was delivered and subscribed to via Apex, for example, in Salesforce.
Ah, okay.
And then it fails for an uncaught exception or something.
So there is no guarantee of reception of message. That's the nature of pub/sub events. There could be no listeners at all, but the event is going to be on the bus, and it can still be replayed during the retention window, that is.
Thank you.
All right, thanks everyone. Again, I'll be standing next to the podium if you have questions. I'm happy to answer.
Yes.
Thank you.
Thank you.